Okay, quick crash course on slope, distance, and midpoint formulas on a graph. Some of those you may have used before, some of them you may have forgotten. So let's get to it and you will be done. So, you should know the slope formula from middle school, from algebra. Slope is rise over run, also known as delta y over delta x, also known as y2 minus y1 over x2 minus x1. You can use any of those that you want as long as you get the answer right. We don't care which one you used. So, I'm going to plot some points, and so are you. Plot these with me. A is negative 3, 1. B is 0, 5. C is 4, 2. D is negative 2, 2. And E is 6, negative 4. So there's A, B, C, D, E. Let's see. What can we do with it next? It says find the slope for each of the following segments. Okay, I can do that. So if I want the slope for AB, whoops, I'm going to draw AB in here. I know that's not perfect, but it lives. So if I want the slope for AB, I'm going to do rise over run because I have a graph. Might as well count on it, right? So I went up 1, 2, 3, 4. Rise 4, run 1, 2, 3 to the right. My slope is 4/3. Yay, go me. Okay, then I'm supposed to do BC, so I'm going to draw it with a different color here. Let's do green. So here's BC. Fine. Let's see. I'm going to do delta y over delta x. So when I do delta y over delta x and I look at BC here, delta y over delta x, y went from 5 to 2, so it went down 3. And x went from 0 to 4, so it went up 4. Negative 3/4. I could have also done that with rise over run again. I'd get the same answer. Moving on, DE. All right, let's change colors again. DE is this long guy right here. All right, DE. I'm going to use the big formula now because that's a lot of counting. So I might as well use this last formula. So DE, here's x1, y1, here's x2, y2, and if I want to use the formula, again, which I don't have to, I'm just showing you all the different options. If I want to use the formula, I'm going to do y2 minus y1 over x2 minus x1. So negative 4 minus 2 is negative 6. And 6 minus negative 2 is like 6 plus 2, which is 8. And negative 6/8 is just begging to be reduced, and it's begging to be reduced to negative 3/4. Okay, cool. And last but not least here, we want DC. So DC is this guy right here. And some of you might be saying, hey, I know what that slope is. Well, yeah, you do. If I do rise over run, I didn't rise up any. So my rise is 0 and my run is 1, 2, 3, 4, 5, 6. 0 divided by 6 is 0. Horizontal lines have a slope of 0. All right, so what do I get out of that? Well, I got to remember some stuff. I got to remember the rules for slopes. But it seems like there might be a reason that like I had these and they look like that, and then the relationship between here and here. What do we see in here? So some things that you may or may not know about slope is that parallel lines have the same slope. Okay, parallel lines have the same slope. Well, which things look parallel here? BC seems awfully parallel to DE. Oh, look at that. BC and DE are parallel. So which two segments? DC, BE. They were parallel to each other. I should probably use the parallel symbol, huh? There we go. Which two are perpendicular? Wait, perpendicular? I haven't said anything about that. All right, well, perpendicular, remember, means forms a right angle. And in coordinates, we know that things are perpendicular if they have opposite reciprocal slopes. Perpendicular lines have opposite reciprocal slopes. Mrs. Pepper, what's opposite reciprocal mean? Opposite reciprocal means you take the fraction that you got for slope, flip it upside down, and change its sign. Okay? So examples of opposite reciprocal would be like 1/5 has an opposite reciprocal of 5/1, but negative. 2/3, let's say negative 2/3, has an opposite reciprocal of 3/2, I change the negative into a positive, done. Okay? So which are perpendicular up here? Well, which one's flipped upside down? Oh, this one. See, I even put the arrow to make you think upside down. 4/3, 3/4, but negative. So AB is perpendicular to BC, and look at these guys. You don't have to draw these arrows if you don't want to. 4/3, negative 3/4, DE is also perpendicular to AB. And if I look at the picture, I can kind of see the ABBC. That really looks like a right angle. And if I extended DE a little bit, I'd see a right angle also. All right, Mrs. Vibber, what do I need to know from this page? I need to know this slope formula from this page, and I need to know that parallel lines have equal slopes and perpendicular lines have opposite reciprocals. You need that. Don't forget it. Page 2. I'm cruising. Distance. All right, so now I got to find the distance between stuff. So take a second and let's plot these points. Negative 3, 1, 0, 5, 4, 2, negative 2, 2, 6, negative 4. Find the length of each of the following segments. Okay, I want the length of DC. Well, that's easy. The length of the line is just, how far it is from one point to the next. 1, 2, 3, 4, 5, 6. There's 6 boxes in between those. That length is 6. Don't make life hard on yourself. If you see it on the picture, just count it. Okay? I'm going to give you formulas. Don't use them if you don't need them. Just count the boxes. All right, what do we got next? BC. Uh-oh. BC slanty. Can't really count those boxes. All right, so now I need to figure out how long is BC. Well, here's what I'm going to do. I am going to almost pretend like I want to know the slope. So I'm going to draw in those rise over run dotted lines and realize that, hey, I just drew myself a right triangle. Here's B. Here's C. I got a right angle here. 1, 2, 3. The right-hand side of it's got a length of 3. 1, 2, 3, 4. The top has a length of 4. I need the hypotenuse. What formula relates the legs and the hypotenuse of a right triangle? Why, the Pythagorean theorem. 3 squared plus 4 squared equals c squared. 9 plus 16 is 25. C equals 5. So BC has a length of 5. Oh, well, that's cool. All right, so DE, let's try and do that again. DE. DE, I'm going to go like this, and I'm going to draw in my right triangle and say, okay, if I want the length of DE, I go down 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4, 5, 6, 7, 8. And I want the hypotenuse. So I have 6 squared plus 8 squared equals c squared. And this is 36 plus 64. That's 100. And I get c equals 10. That's how long DE is. Okay, CE. Mrs. Vibber, my diagram looks really messy and I don't want to draw anything else and draw those dotted lines anymore. Can't I just have a formula? Sure, you can use a formula because there's a nice happy formula. If you want to find the length of CE, there is a formula that goes with it. When I drew in these dotted lines, what I really did is I figured out how far horizontally I need to go to get from C to E. I needed to find delta X. And then I figured out how far vertically it was from C to E. That was a delta Y. Okay? So when we did that Pythagorean theorem thing, I was doing the Pythagorean theorem with delta X and delta Y. Okay? So when I go to find the length there, delta X is 2, delta Y is 1, 2, 3, 4, 5, 6 down. I really end up with the square root of the sum of delta X and delta Y. So here's a new formula. the distance formula is really delta x squared plus delta y squared square rooted. Because if I took that Pythagorean theorem, my a is delta x, my b is delta y, and the distance we want is d. If I solve for d, I just square root this guy, right? So my distance is the square root of 2 squared plus 6 squared, which is the square root of 40. And we'll talk about when you need to reduce that later. I'm not going to do it right now. How am I doing on time here, people? Ooh, 10 minutes already. I got to pick up the pace. All right, square root of 40. All right, so what did I learn here? I learned that if I want to find the distance between 2 points, option 1 is to draw a right triangle on the graph and use the Pythagorean theorem. So option 1 is draw it on the graph, use the Pythagorean theorem. Works great. But if you don't have a graph or you're not very good at drawing it and you're always afraid you're going to miss something, there is a formula too. And option 2 is the distance formula. The distance formula is delta x squared plus delta y squared. But delta x and delta y from slope can also be written as x2 minus x1 squared plus y2 minus y1 squared, because that's still your change in x and your change in y. You can use any one of those you want, find the one that works for you, and get the answer right, and we are happy campers. All right, cruising. This last page shouldn't take long. Midpoint. Midpoint means the point in the middle. All right, point in the middle. So I'm going to go as fast as I can here and plot these points. So I have negative 3, 0, 0, negative 5, 5, 0, 1, 1, 5, 3, A, B. What am I missing? That's supposed to say B. No, it's not. This is Viver. Get your head on straight. 0, 5, 5, 0 is B. There we go. Okay, so everybody's lined up. Cool. Find the midpoint of each of the following segments. Okay, so the midpoint of AB. I made it easy for you. AB's flat. Okay, horizontal line. If I want to find the middle, let's see, it's 1, 2, 3, 4, 5, 6, 7, 8. AB is 8 units long. The middle would be 4 away. 1, 2, 3, 4. There's the midpoint. That midpoint is 1, 0. Easy peasy. Now let's look at DC. DC is vertical. Easy peasy. Negative 5 to 5, that's 10 units. What's halfway between negative 5 and 5? Well, that would be 0. Midpoint of DC is the origin. Uh-oh, EF is slanty. EF. All right, the middle's like somewhere in here, but I'm not quite sure. How do I figure out the middle? Well, the middle is halfway. One way to think about that is to say to get from E to F, I got to go up 2 and go over 1, 2, 3, 4. So if I want to go all the way from E to F, I go up 2 over 4. Well, what if I only want to go halfway from E to F? Then I'd go up 1 over 2, and then I'd get to the middle. So what's that point? That's the point 3, 2. But again, what if you're like, ugh, I don't know that I can graph that. I might lose count. What can I do instead? Well, what we're really doing is we're finding the middle. We're actually finding the average of the coordinates. So if I want DF here, and I want to find its middle, D is 0, negative 5, and F was 5, 3. To get the midpoint, you literally average the coordinates. So 0 plus 5 divided by 2, that would get me the average of the x values. Negative 5 plus 3 divided by 2 would get me the average of the y values. So let's see, 0 plus 5 is 5, 5 divided by 2 is 2.5, negative 5 plus 3 is negative 2, Negative 2 divided by 2 is negative 1. 2.5, 1. 2.5, negative 1 is right about there. And now my line's not perfect, but we can assume it's supposed to be on there. So there's my middle. La-ti-da. Okay, last but not least, what did we just learn? We learned about midpoints. Midpoints are technically the average of the x and y coordinates. And your midpoint formula is add the x's, divide by 2, add the y's, divide by 2, and you will get your midpoint. And the most important thing before I sign off here is you need to graph all of this. If you're not graphing it, you are hamstringing yourself. Graph it, graph it, graph it, and check your answers on the graph. I always end with a joke, so because it's rainy and it's near Halloween, why don't ghosts like the rain? Because it dampens their spirits. All right, enjoy your day.